Hi all, welcome to my YouTube channel Know About Embedded System. So in today's video we will concentrate how to develop an embedded C code for hex keypad, nothing but hex keypad programming. Okay, so in the previous video I have already explained you what is hex keypad and how the internal design has been designed. All these things I have already explained in the previous video. Please watch my previous video. I'll update the link in the description box. So today we will concentrate how to develop a C program for your hex keypad. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video. Hex keypad programming. Now, how to develop the code? If you want to develop the code, we have to follow some three major steps are there. One is called initialization. Second one is called row scan, and third one is called column scan. In the initialization part, some 4 to 5 major steps we have to do. So what we have to do? So we have to include all our LCD files, and we have to define columns and rows. So rows are defined from 2.7, 2.4 to 2.7, and columns are defined from 2.0 to 2.3. And then we have to initialize your LCD, and then here you can see we have to monitor key closure in the row scan in while of 1. So we have to continuously check whether key is pressed or not in the while of 1. So inside while of 1 we have to perform row scan. If any key is pressed, if the row scan is identified any key, then we have to jump to the column scan. Three major functions. One is normal initialization, then row scan, then column scan. Now how to perform row scan? To perform the row scan, here the steps we have to follow. Again, here also 4 to 5 steps are there that we have to follow. So configure rows as an input port. Which scan you are doing, those ports you have to make it as an input port. I am performing row scan and I want to make rows as an input port and columns as output port. This is first step. Then read the row status. Read the row status from FI open register, load into the one of the local variable, and right shift by 4 position to get as an LSP. And then after doing that, we have to check the pattern here. You can see if the row scan is returning the pattern of 1110, then I can say that row 1. Similar to that, if it is returning D, it is called a row 2, and it goes on like that. So this process is called as row scan. Similar to this, we have to perform a column scan as well. Column scan exactly same as row scan with a small difference. In the column scan, columns we have to make it as a input port and rows as an output port. Then read the column scan, read the column status, move it into one of the local variable, and then right shift by 4 position and compare the pattern here. So we have to compare the pattern. 0E first row first column, 0D second column, and 0B third, and 07 is fourth. So like this we have to perform row scan and column scan. Okay, one more last point is that after that we'll go to the coding part. Now you can see here, so this is how the key matrix looks like. I already told you we will have 4 rows: row 1, row 2, row 3, row 4. Row 1 will correspond to one set of switches. Those switches can be numbered like this: 0, 1, 2, 3, row 2, 4, 5, 6, 7, and it goes on like that. Now after identifying the row, we have to perform column scan, in which column the key is pressed. That is called as column scan. For each row there is a one column scan. For row 1, I have column scan 1. Similar to that, for row 2, I have column scan 2, which corresponds to 4, 5, 6, 7, and row 3 will have column scan 3, where I can identify 8, 9, AB, and similar to that, row 4 will have column scan 4, and I will be having the numbers C, D, E, F. Like this, every row, whenever there is a row is identified, the corresponding column scan will be there. So totally I'll have 4 column scans: column scan 1, 2, 3, and 4, and 1 row scan. So totally 5. Let us move to the coding part. So I have already done some basic coding, nothing but initialization part I have already done. Here you can see I have already defined my rows and columns, and also the function declarations I have done row scan, column scan 1, 2, and column scan 4. So totally 5 functions I have declared. And here my clock configuration I have done, LCD configuration I have done, UART configuration and I have done. In while of one I am performing row scan. So we're not worried about the main program. Main program is very simple. So just we are concerned only about our row scan and column scan function. So in the row scan, what is the main functionality of the row scan? The main functionality of row scan is to identify in which row the key is pressed. So first we have to identify in which row the key is pressed, and later we have to jump to the respective column scans, right? Now, so we have to, I already given the instruction that we have to follow. The first one is columns. I have to make it as an output port, rows as an input port. To do that, so we have already different registers are there. So GPIO 2. So we have to follow F5 dir is equal to rows, columns. Since I'm doing a row scan, columns will be output port and rows will be input port. Columns I have to make it as an output port, and I have to make rows as an input port. Copy this. Now I'm going to perform the rows as an input port is equal to negation of rows. So this line, whatever you are seeing, this is going to configure rows as an input port. Line number 33. Line number 33 will be configuring your rows as an input port. So columns as output port, rows as an input port. After this, I have to read the status of your row. How to read the status? We have a dedicated register is there, that's called FIO pin. FIO pin stands for fast input output pin status register. This register is used to read the status of port pin. Perform AND operation with rows, and then you can take it into one of the any variable. I have already defined one variable here, that into that variable I will load my row status. Okay, so this is my third point I need to understand in the row scan. Now after that, I need to shift the variable value by 4 position to get it as LSB. So why we have to shift right? I want to get it as an LSB. That's why I'm going to shift right by 4 position. Okay, so now var right shift by 4 position. So this is going to create this is going to shift your row status into LSB position, and after that I have to compare the bit pattern. For checking the bit pattern, you can use if statement as well, or you can use a switch statement as well. Anyone, whichever you are convenient, you can use. For me, the switch condition is a easier way. That's why I'm using here switch case with a bit pattern. So I have a 0E first row, 0D second row, and 0B third row, and 07 is fourth row. We have already discussed. So now what I have to do? So if I need to jump to column scan 1, if the first row, this is called first row. This is my first row. In the first row, jump to column 1. If key is identified in the first row, then jump to column scan 1. I need to jump to column scan 1. How to jump? Just we have to call the function call here. Call underscore scan 1. This is my function, column scan 1, and then just you can break it here. You can create one break. That's it. So in the row scan, just to identify in which row the key is pressed, there is nothing major thing we have to do in the row scan, only to identify the row position, then jump to respective column scan. So now In the second case, I'll be going to column scan number 2, and identified is a row number 2, and I'll be jumping to column scan. Exactly same thing we have to perform for column scan 3. We have to jump to column scan 3, third row on column scan 3, third row on column scan, jump to column scan 3, finally fourth row column scan 3, fourth row column scan 4, column scan 4, and then fourth row jump to column scan 4. So like this, I have to develop a row scan. In the row scan, identify the row position and jump to the respective column scan functions. The first function is completed. That is called row scan. Okay, I hope you are clear. Now what we have to do? We have to write a column scan function. So to write the column scan function, I'll just copy the same row scan and I'll do the modification in the same function. Now I'll be writing the column scan 1, call scan 1. But before doing that, we have to do the small changes here. Rows as an input port. In case of column scan, rows are going to be an output port and columns as an input port. Columns as an input port, and here the calls will come. So rows become output port, columns will become input port, and then here I'm going to read the row position, column position, then I'll be right shift by 0th position. So now the important things, now here I'll write column scan. Here I'll write call scan 1. Column scan will have 0, 1, 2, and 3. So these many characters will be there. So we have to remember this. So in the column scan 1, I need to print 0, 1, 2, 3. So for printing, you can use either LCD or you can use UART. I'll be using UART here. str UART string double quote. So I'll be printing here 0. Okay, and then I'll take the next line here. So this is your new line /r. So this is only the printing part 0, and this part whatever you are seeing, this is your new line character. This is actually print, and this is used to new line or next line. This is new line function. /r and /n are new line commands or next line commands. Okay. Yes. Now I'll just give a small delay here. So now the first part is done. I have printed 0. The same thing is applied for then 1. This is 2. Then this is going to be 3. Okay, so 0. This is going to be 1. This is going to be 2. This is going to be 3. I hope you are clear now. So what we supposed to print in the column scan 1, in the column scan 1, according to our previous design, it has to print 0, 1, 2, 3. So that's what you are printing here: 0, then 1, then 2, then 3. Right. So this is my column scan 1. Now I will copy the function column scan 1 and I will write as a I'll modify the code and I'll rename it as column scan number 2. In the column scan number 2, what are the numbers we have to display? We want to display 4, 5, 6, 7. This is my column scan number 2, 4, 5, 6, 7. Here 4, 5, 6, and 7. Column scan 2 should have characters 4, 5, 6, 7, and rest all the things will be same. only the numbers will change. So this is 4, this is 5, this is 6, and this is 7. Similar to that, so now the column scan 2 is completed. Column scan 2 is complete. So in the column scan number 3, what are the things I had to print? In the column scan 3, 89AB, I had to print 89AB, 89A and B, and function name is called column scan number 3. So let us print that 8, 9, A, then B. So now the column scan 3 is also completed. The now last one is column scan 4. The column scan 4 is CDEF. So I'm going to change the function name, column scan number 4. In the column scan number 4, CDEF, the characters to be printed is C, characters are need to be printed is printed like CDEF. We have to print CDEF. So I'll be printing C, then D, then E, then F. Only this much. This much is the coding part. Okay. So totally 5 functions we have written. I'll just come from the top. You can see this is your macros, rows and columns, and one row scan function to identify in which row the key is pressed. Then column scan 1, 2, 3, 4. And this is your main code. In the main code, we're not doing anything, just we're calling the function called as a row scan here. Only this much is a main code. Very simple. Just initialization and continuously monitoring the row scan. Okay. In the next row scan function, we have to follow the steps what I have explained in the previous slide. So that part we have to follow. And row scan is mainly to identify in which row the key is pressed. If the pattern is 0E, the first row, and jump to column scan 1. Similar to that, the 0E, row 2, jump to column scan 2, and it goes on like that. So this is my row scan, and in the column scan 1, so I'm going to print 0, 1, 2, 3, and it goes on like that. Then it's column scan number 2, then column scan number 3, and column scan 4. So like this. So we have already written the code. Now we will check for compilation, then we will flash the code. I'll compile. Okay, so there is no any error. It is fine. We will flash the code and we will check the output in the terminal, evart terminal. Now you can see here 0, 1, I can say I'm pressing actually 2, 3, 0. Now you can see 0 and 1, 1, 1, 2, 2, 2, 3, 3, 3, 4. This is 3, 3, 3, 4, 4, 4, 5, 5. So there is actually short 7. You can see 8. AAA, so BBB, you can see like this. C, D, E, F, F, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So like this, we're able to get the output. Okay. So I hope this video is clear to all. So if you feel this video is an informative video, please click on like button and subscribe to my YouTube channel.